Good morning, everyone. A warm welcome to the second day of our faculty development program. A warm welcome to all the participants here. I hope yesterday's session were informative and thought-provoking. Today we have another exciting lineup of sessions and discussions. Let's get started and make the most of this opportunity to learn and grow together. Today, the second day, the first noon, we have our guest, Mr. Rajkumar Ukkuturi, founder and managing director of Mekuva Technologies, Hyderabad. He has completed his BTech from JNTH 2017 and he has also completed his PGDM from Central Institute of Tool Design. He has an experience of 8 years. His position allowed to gain knowledge in conventional manufacturing techniques like lathe, milling, grinding, surface finish, heat treatment, engineering material applications, welding and CNC, etc. So later he decided to go for further studies, that is, as said, postgraduate diploma in tool design, CAD and CAM. And also he has interesting subjects like design of injection molds, jigs and fixtures, press tools, product design using advanced CAD software like AutoCAD, SolidWorks, Siemens NX, Creo and CATIA V5. He also learned to code G-code to run CNC mill, lathe, laser cutting and EDM wire cut using software like Mastercam, NXCam, and also he learned different rapid prototyping technologies like 3D printing, FDP, FDM and SLA, and how to reverse engineer a part product using calipers, photos and 3D scanning. Currently, he is running his own startup business called Pvt.Ltd, that comes under 3D Printing Service Center provider, and Mekuva Technologies Private Limited is 3D printer manufacturing company. So this is what our guest has today, Mr. Rajkumar Ukkuturi. We welcome you all, sir, and the session is all yours. A huge round of applause, everybody, for our chief guest today. Will you start?
Yeah, I'll start directly. So Mekuva Technology is a technology startup. We are into manufacturing 3D printers. Also, we provide 3D printing services. To support our ecosystem, we also provide training and programs in schools and colleges. So the reason why we exist is let's see, in the market there are many brands of machines are available. Let's say the customer wanted to print a Statue of Liberty, but he ends up getting a part that is fall down, or these machines are not reliable. Mekuva Technology solves this problem by providing industrial 3D printers to the customers. Like all our machines are made in India, made in Hyderabad. So our machine's uniqueness is services like customer support, and next one is the on-site reliable support to the customer. These are our product range. We have machinery starting from 200 build area to up to 1 meter build area. So apart from 3D printers, we also provide 3D printing machinery, services, learning courses and software. So Mekuva Technology you can consider as a one-stop solution for all your 3D printing needs. So in this workshop, we'll understand 5 key points. Like first thing, what is biocompatible materials and what are green and biocompatible materials, and what are the technology techniques and use cases, and most important one, why it is very important. Like generally where the waste is producing, how we can tackle this one. So everyone have heard of this name called additive manufacturing. Some people call this 3D printing. Some people call it as rapid prototyping. Some people call it as direct manufacturing. When we see the real objective, like all these names comes under the same term called additive manufacturing. Like if someone says like it's rapid prototyping, it's same. It's belongs to additive manufacturing. If someone say it's rapid manufacturing or direct manufacturing, these all terms comes under the same thing called additive manufacturing. So we can see a few parts that were printed on a 3D printer. Like some are aesthetically good looking, some are medical grade, some are fashionable, some are engineering oriented. These all parts are made using 3D printers only. So we can see using 3D printers we can make anything. It's not just limited to a few components. We can make a lot of things out of it. So if we see the market valuation, how this industry is growing, like this industry, if you see final production, let's say right now people are not just using this technology for making prototypes. Prototype means just to test whether the design everything is good or not. They are using it to produce end use parts. Let's say if you have a part in your car, most probably you will see a lot of parts 3D printed in future in any car or local bodies. So if you see the chart where exactly the 3D printing is utilized in the industry, like if you see almost 33.3% is belongs to prototyping. That means people just use this to produce like testing form fitment parts or concept models, all these things. So why it is mainly important, like why we need to why it is more important in green materials as well as in other technologies is like during the COVID period everyone has seen like there was huge disruption in supply chain. Like there were people, like medical system was completely overwhelmed and many parts are not available, like ventilators or multiple things, because we are heavily relying on China for these supply chain problems. But this exposes the fundamental problem that's lying in the ecosystem. So that can be solved using 3D printing because we can locally manufacture all these parts. So next thing comes is Industry 4.0. Another importance for the 3D printing industry. Industry 4.0 is nothing but like you manufacture parts without like everything is connected to big data. Let's say example, the courier services everyone is aware of. So how the courier services are working effectively is because of the big data. Like all the parcels which go from A to B has to be, let's say if you have to manufacture a part, so in order to manufacture that part, main thing how you need to do is raw material has to move from part A to part B. Then only the part get manufactured. If you want to manufacture a car, it has a lot of parts involved in it. So if you move every part individually, like there is a lot of movement is happening one place to one place. In this process, a lot of materials is getting wasted. Like if you have a system where this entire process is managed by big data, so what it's gonna do is like it's gonna save a lot of resources. Let's say if you are manufacturing one part, some other person manufacturing some other part. If all this data is gathered by big data, so one great thing happens is like everything the system will say the easiest path to move the supply of these materials to this area. In this particular area, uh, the availability of this part is higher, so we can save a lot of resources, like a lot of fuel can be saved to moving these parts, as well as the 3D printing also. So how these courier companies are working is using this data, so they can gather all the information and put different parcels in different locations so that a lot of fuel is efficient. Similar way, using 3D printing also, we can make this thing happen. Like we have hundreds of machinery, everything is connected to internet or big data that will effectively utilize the resources in a proper manner, so nothing is getting wasted. So these are few advantages, disadvantage using 3D printing or this one. So before getting into the main applications and what are biocompatible materials and different thing aspects, we'll first think what are currently people are using. Use these 3D printers, how they are utilized in industries. So we'll cover different industries like teaching industry, tooling, aerospace, every one of them. So first one, teaching and training. Like the best example is this one. In your college or in different areas, let's say uh, there is a word saying like a single picture worth thousands of words. A single picture, let's say if I show a picture, that is equal to thousands of words, saying 1,000 words of words. So similarly, a single 3D printed part can be equal to lakhs of words, simply I can say, because we everyone know, like when we read something, when we read a article or we watch something on internet, we watch, let's say if you want to understand how a mechanism works, if we read it, we our brain understands it better compared to watching a video or audio recording, because our brain processes text information differently. That is the reason when we read instead of watching a video, our brain remembers it better. That is the reason still book reading is far better than watching a YouTube video or a audio recording. Similarly, the 3D printed part, if you have a physical object in your hand, so you can have your learning process almost 2 times faster. So that is one good example. Like we can print a lot of mechanisms, a lot of concepts, different parts. We can directly 3D print. That is one good example of applications of 3D printing. Next one is aerospace. This image simply tell you, like let's say this part is having this much bigger one, so that has become very smaller. So we have reduced a lot of weight, so that it will save us. Like in airplane, every gram weighs, every gram is gonna increase the fuel cost of it. So that can be saved using 3D printing. So in medical industry is the one which is going to be benefited from this technology the most. Let's say you can print organs. People are printing organs. Like let's say some person might have lost their ear. Let's say they have lost the ear. So simply what they can do, currently people are doing is, they are taking the biomass of the person, they are taking the dead cells of the person, and using the dead cells they are printing the object. Like let's say uh, there is a heart problem, so people can directly print a heart. That is not happened till now, but it's gonna happen in future for sure, where people can take the real tissue of the human, and from that they make these 3D printed organs, and those 3D printed organs can directly be utilized on a human, and uh, they can be used to save the millions of lives. So that is one great example. Fashion industry is the one of the greatest example for fashion industry. Let's say ornaments, dresses, like you name it, a lot of things people can make it out of 3D printing. Like we are seeing this trend currently. Uh, People are printing multiple objects because there is one saying like, if the clothes fit your body correctly, so you will look more attractive. So similar manner, if you wear something clothes which are exactly your match, which will fit exactly to your clothes, that can be possible because we can scan a person completely, and we can give softwares that will cut the exact frame length, we can stretch it. So these things can happen using 3D printers much better. Also 3D printer shoes. So Adidas and Nike, they have already announced and already launched the product also to the market. 3D printed shoes. They are having much better reliability while walking, or multiple activities can be done faster. So in this post you can gather all the information about it. Adidas, Nike, they are already into it. So future of 3D printing is simple. Like you simply ask a person to walk on treadmill, and he will the machine will gather the data, how the footprint of the person is. So you can make a sole of it. So that is more uh, much better, more comfortable to the person, and he will have not have different health issues also. If you have a shoe that fits exactly to your shape of the foot, that is more better because the loading can be uniform. So the gold industry is using the 3D printing the most. Like Lalita Jewelers has thousands of 3D printers in their arsenal. Like they are completely printing all the ornaments you see, gold ornaments. They are mainly made of 3D printing. Means they first make the part using wax 3D printers and they cast it. Uh, this is the process they are programmed. Movie industry is the best example of the application for the 3D printing. Let's say there is a saying like, the best movies are the one which are not just made, not just seen, they are also felt. Like if you see the best movies like Thor, Avatar, in these movies you see number of parts are directly 3D printed. They are not simply using CGI effects. They are using the 3D printed parts to give the viewer the expression like 3D. Sorry, the viewer can see they just felt the movie in their eyes instead of just seeing something. So the best movies are the one which use less CGI and more real objects. So that one example. So construction 3D printing is one of the best example. Maybe Lord's College might also purchase a construction 3D printing feature and install there. So construction 3D printing, you can simply, let's say there is a flooding happened in particular area. So many people lost their homes. So if you want to rebuild a rehabilitation sensor, so 3D printing can help easily. Like let's say if the humans want to colonize Mars or Moon, so they cannot bring materials from Earth to the Moon. So they have to rely on some materials which are locally available. They mix with some binder material and they can start constructing their homes directly. And food industry also one great example for 3D printing. Like let's say if you have a like if you have your food in good decorated manner, you will feel it easy to eat. Not easy to eat, it will feel more attractive to the person to eat it. So that is one good example for also you can monitor how much calories you are consuming. Let's say a human person has to consume good amount of calories. That is also good amount of fats, vitamins, protein, everything. So if you have a 3D printer, if you click on it, it will automatically print the food. But you also get the data like on your phone, like what is the consume you are doing, like you are overeating or undereating. So everything you can monitor. Like, so now we come to the main reason why biomaterials and uh, is having the most significant importance. Let's say I want to manufacture this watch. One simple example. So the if I want to manufacture or design this watch, first thing is I will make a concept of it. So as we earlier seen in the chart, so 3D printing is the having number one application. Number one application for the 3D printing people are using is prototyping. Prototyping means just testing the model, whether it fits, form, everything is good or not. That is the number one application. That means, let's say if I have to manufacture this watch, if I have to manufacture something, so first what I do the concept. Concept means like how it looks. I put a sketch on a paper. I'll make the 3D model. I'll just print it and see, okay, concept wise whether it's good or not. Next one I'll do designing. So that also I'll print it. Let's say, let's example, there is a recent interview with Airbus. So in their model, they have printed total of 1500 iterations. So before launching the plane to the market, they made 1500 iterations. That means 1500 planes they have made and tested. Then they come up with that model, complete particular model. That means if you see every product, if a company manufactures these many prototypes, these are not the one which are giving to the consumer. These are just prototyping before giving to the market. People are producing a lot of prototyping. So that is going to happen every day. Like this is, like we can see a lot of waste is getting produced here. Like in order to make this watch, first I will make the concept, design, just prototype it and then test it. If it everything functions, everything is good, okay. If not, means I will again do the same process. So again I design it, again I change the design little bit, form, fitment, everything. This is a repetitive process. So unless I'll get the perfect design, so in this process the majority of waste is getting generated. So as we already seen, number one application for 3D printing is product development and prototyping. So that is the main reason. So one thing people are going with 3D printing in product development. Product developments, let's say if you manufacture anything, camera stand or anything. So first you test it before going for the mass production. In tooling, you before investing on tooling, you just produce 1 or 2 units using 3D printing to just test the test form, everything. So one advantage is acceleration time. So it will accelerate the time to market. Like let's say if you go with the manual manufacturing method, like how many of you gone through a manual manufacturing method anyway, like anytime, like contacted vendors from Balanagar or different area to produce a part? Anytime have you gone through? Have you produced any part through, like any part, metal parts or plastic parts, anything? Have you made through vendors? So if you have done, means you will hear only one word always saying. They will say like kar raha hu, karunga. These words only they will keep on saying. Then let's say if you want to manufacture a small part also, they're gonna take 1 week time. It will simply go away. If you think like the same thing will happen with thousands of parts if you have in your design, it's gonna simply ruin your 1 year, 2 years, 3 years, and your product never gonna reach market. So that is the one thing. 3D printing gives one best example. Like you can simply design the part in the morning time, and by the night you can directly start put it for printing. Morning you come, you have a product which you can test and evaluate whether to go with this design or change the design slightly different or everything. So the number one example, like where the 3D printing is getting utilized in product development, is concept models. Like you just see how the fitment, everything is, appearance models, form fitment, whether it's fitting or not, whether there is a tolerance issue, if it not fit, whether all wires can have enough room to pass through, wires have all holes or not, everything to check, everything. Functional part, you test it, you try to bend it, whether it's breaking or not. All these things you do. This kind of 4 things: concept, appearance, form fitment. These are the general things people do in a day-to-day basis to design, manufacture any part, any to launch anything into the market. So this is a very important one. So by one example, this is given by Stratasys CEO, not by me. So time to market is reduced by 90% by using 3D printing. So that is the reason 3D printing is the number one application for product development companies. And next one is tooling. The What does tooling means exactly? Anyone can say the definition of it? What is the tooling means? What is the definition of tooling? Tooling. Yeah, tooling means tools. Let's say what is tool? What is called a tool? Everyone is mechanical, right? Okay. What is the meaning of a tool? What is the meaning of a tool? No, that is not. That is not the definition of tool. Any other answer? No, sir. That is also not correct answer. What is the meaning of tool? What is the definition of a tool? Like we see this, hear this word a lot of times, right, in your mission books everywhere. What is a tool? Tool means. Okay. So you can. Yeah. Somewhat correct. Somewhat correct. So this is the definition of tool. What is a tool means? Any physical object that is used to enable the manufacturing of induced products is called, or prototypes is called a tool. Let's say the tool, cutting tool is there. That is a tool, but it's not just utilizing for the cutting. You can also call the tailstock also a tool, which is aiding the manufacturing of a process. That is called tool. Anything that is aiding the manufacturing process is called a tool. So that is a correct definition of a tool. Physical components used to enable manufacturing of induced products or prototypes is called tool. That is the correct definition. So in this video we can see like how 3D printing people are using in tooling industry. After that we'll understand what are biomaterials, everything. I think you cannot see the audio of it, like maybe there is no sound.
Plastic, predominantly used to make jigs and fixtures, machining them out of aluminium or steel.
So you can see these are all jigs. They are using those jigs to like drilling purpose. Like just say in injection molding or casting, you cannot have holes. So using the jigs, they can easily drill holes, and they can also put the names of it on the directly part. So for inspection, jigs will be required. Inspection tools required. Many applications it has.
Using jigs to help us cradle parts while we assemble them, so it aids us in the assembly. The main problem with the traditional method of manufacturing jigs is it takes up a lot of time for the tool production.
So everything. This is the one best example and best use case of 3D printing. So let's say what happens to this tooling. Like the person has made a tooling to drill holes, sight holes or something, or to sticker it. Let's say I want to have a branding sticker. Exactly, it has to come in the middle. So I cannot put a sticker directly. I have to make a jig, so that using that I can locate and put the sticker exactly in the correct position. Car companies use these jigs every time to put the labeling, small adjustments they have to make. So after this process completed, this tooling they are simply gonna throw out. Like they're not gonna use them multiple times, because here is the place where all the wastage is happening. Like in product development, you can see in order to manufacture a part, concept, form fitment, functional prototypes, everywhere you are producing, keep on printing parts to test your model. It's simply creating a lot of wastage. So that is one major thing. So another example we seen during the COVID period, where the supply chains were suddenly disrupted, like getting parts from China was very difficult. During that time, many 3D printing companies, including us, we printed face shields, face masks for the doctors, for the local policemen. To like these are ventilator part. It was not available at the market, so someone designed it and directly 3D printed, because 3D printing is faster process injection molding. So face mask, like you can scan your face and you can make a mask that exactly fits your face, so you'll feel more comfortable wearing the mask for longer period of time. So door handles, these are all printed just during this COVID period in a very short period of time. So in defense and space, also one good example. Like recently in Ukraine-Russia war, one best example I can see. Like during the starting of the war, Ukraine not even having single small equipment, also defense equipment, but they were able to stop Russia using only drones. Like they printed cheap drones, and they simply the drones they connected the 3D printed parts, and they just put 2 grenades into it. So when you press the button, it will automatically drop the grenade on the shell. So like that also they have created. Yes. Yes. Okay. Yeah. Okay. Okay. Sure. Sure. Okay. So in defense space, this is the one best example. Like you have some parts broken, so you cannot waste time till the from mainland the part has to come. It is not going to happen easily because you are in a very tough situation. But if you have a 3D printer with you, like it can save the lives of the person also. Let's say a particular person has some injury happened during the conflict, so he needs some medical surgery, so he cannot wait for the part to come from the mainland, or they cannot move him from one area to other area, so they cannot procure the parts. Using 3D printer, you have the digital library in your pen drive. All the parts you have in a single pen drive, where you can print it. So that is one best example where 3D printer parts are using in defense industry. So why I am showing the main application part is because we want to know where the 3D printing waste is going to produce. Because end of the day, this is Earth is the only one. We have only one Earth. If we not going to take care of it in future, many things will happen. Like we will not have good life of living if we don't care of our planet. So this is where all the waste is getting come into the picture. So medical industry, you can see in this video. So how people are using 3D printing in medical industry, especially. So in this video, you can see how 3D printing is getting utilized in surgeries, especially. So this was the surgery done in 2003. So you can see it was almost 10-12 years. But during that time also, like you can see the both kids were born with same head. So if the surgery was not done, they both guys would have died. They have to complete this operation. First they printed the babies on a normal one, and then they tested it. That is a 3D printed part. So you can see the surgery is getting happened. But before the surgery, like the doctors have practiced on a 3D printed part. Like they have machines in the market. There are a couple of machines which can print human tissue, like which is having similar hardness as a human tissue, like blood vessels, all these things. So you can see that is 3D printed part. So before going to the surgery, the blood vessels, everything you can see inside. So this kind of planning we can do using 3D printers. So before these advancements, the surgery would have been very difficult, but 3D printing aided. So another good example is medical implants. Like currently, any bone right now it breaks, it is most likely it is made of 3D printing only. 99% currently all the bone implants are getting done using 3D printers. Main because 3D printers have porosity. This porosity helps the bone growth much faster. And also people are experimenting materials. Like let's say if you implant something from part into the body, over the period of time the part get consumed with the body and there is no implant. So there is no need of the implant to be removed after some period of time. So there is also one great example. So now we come to the main problem. Why biomaterials and biomaterials is the most important one. First thing you can see, like during the printing process, there is a lot of wastage is happening. The parts support material is wastage. You can see the first part, it was having some defects, so it was thrown out. There is some more parts. The part multicolor printing, it also has a lot of wastage. So this all getting thrown in the to the garbage. So it is simply creating a lot of environmental pollution. Like let's say in your home also, if you separate wet garbage with dry garbage, it will be super easy to recycle it. But people are not doing, because it's the attitude of the people. It's not gonna change simply if we ask them to do. So same thing happened in the 3D printing industry also. This scrap is simply throwing out, even though somehow the metal can be utilized. So this is the reason we should be more focused on uh, these green materials. So what are green materials exactly? Green materials, sustainable materials with low environmental impact. Let's say you print currently the polylactic acid plates are coming, which are more biodegradable. Like you can simply put it in soil at some period of time and they get destroyed. So those kind of materials, like some examples which are currently 3D printing, people are using in 3D printing. What is PLA? Next is wood fill, algae-based PLA, and recycled PLG. So these are the few examples for uh, green materials currently people are using in 3D printing. So next one is what are biocompatible materials. Biocompatible materials means which are contact with human body. Let's say earlier I explained titanium implants. The generally in 3D printing there is one more thing, like you cannot use metal parts in your skull. People mostly use plastics in their skull for cortical implants. Main reason key, like if the implant is in the head is metal, the patient always feel there is something in their head, so they cannot use metal implants in the head. So they have to use materials like PEEK, which is plastic that is having equal strength as aluminium. So chronicle implants one good example where 3D printing FDM can be used majorly. And orthotics, let's say you have fractured your bone, so you cannot write for a particular time. Using some prosthetics like you just wear them and you can hold the pen little bit. You can simply write little bit of words is possible. So that is one good example. Some other materials which are certified for skin, FDA approved, like which are having COC certified materials can also be used in biocompatible materials like prosthetics, surgical guides, everything which are not reacting with the human body. They can be termed as biocompatible materials. So orthotics is simple thing, like you ask the person like just wearing a shoe. Orthotics nothing but anything that is externally used things. They are not breathable, always irritating to your skin. Like when you place it, it will be too uncomfortable. People who wear it might have experienced this problem. So if you have 3D printed one, so okay, you can take it out. Like if you have, generally people don't take it out if it is broken, but if it is small injury, they can use 3D printed prosthetics. And one good example, during the COVID period, everyone might have faced this problem. People has to wear mask for over extended period of time. It was hurting our face a lot. Many people don't want to wear mask also. Main because key, this mask if you wear them, it is only putting pressure on some parts of the face. So that is the main reason people are uncomfortable wearing those masks for long period. So if we have a 3D printed one, we can scan the person. Like during the time I seen even apps also, they are mainly supported for iPhone. So they can, using iPhone, they can scan the person and they can get the 3D model. On top of it, they can make this small structure so that they can put it on their face for more comfortable feeling of wearing the mask. So next one is dental implants. These are the number one application. The Invisalign you see in the market, they are actually they are not completely made of 3D printing, but 3D printing aiding them to manufacture the guides. They first 3D print it and then put the thermoforming process to make it. This is different case. In this one, directly the person is printed, and for drilling the hole, he is using the guides. Custom braces and teeth alignment. Currently, people are not directly using, but another example is this one: biocompatible materials. Like you can print a tissue, human tissue, like taken from your own cells, from dead cells of your body or anything. They take the your real body tissues and using that they print the part. Let's say if you lost your ear or some other component of your body, like any organs, like if you have your own body organ on own organ tissue or cells, it will adapt to your body faster compared to something. This is a 3D printed part made of bio ink. Medical implants, one best example. You can see the lattice structure, so that is helping the bone to grow faster. So multiple things you can see. These are all made of using 3D printers, mainly made of using 3D printers and 3D printing technology. So this is the This is the reason why we should focus more on sustainable materials to print these things, like mainly in biomaterials. Let's say prototyping, one good example. Prototyping is product development. If you are designing something, if you could make the part using biodegradable materials like PLA, recycled plastics, it will help the environment better, because end of the day you will be keep producing a lot of parts of this. So common green and biocompatible materials example is PLA. PLA is very widely available. The parts you see here are some of them are made of PLA only. And PETG, recyclable, like PET bottles we can recycle it. All the Coca-Cola types of bottles you see on the market, which can be recycled again. And wood fill, like we can put 30% wood powder and 70% PLA binder to make a wood fill PLA for normal things like aesthetical modes we can use. IG, PLA, these are few biocompatible materials readily available in the market, which people can print and further prototyping or medical usage. So these are biocompatible materials. Some of the other one which are certified. So skin contact, bone implants, PEEK. As I mentioned, conical implants, all conical implants. People are using PEEK. PEEK is a plastic, but people are using it mainly for the head implants, because it has to be lightweight as possible. Bioresins, like surgical, dental, everything. So how these biomaterials are getting manufactured in real time using these technologies, like FDM is a more widely available technology. You can purchase a 3D printer for 20,000 rupees also from market. And SLA DLP, one good example where you can make very aesthetically good looking parts, even strength also good. SLS, very strong parts, functional parts. You can directly give the customer the part also. You can use it on the real life. Bioprinting, using bioprinters are available. You can use tissues, bio ink to manufacture a part. So how these materials are made? PLA is starch based, like corn. It's made from corn. The grains, they convert into polymerization, recovery, and then they make the pellets. PETG is simple, like you take the PET bottles and crush them and grind them and make the reused. And PLC, there are a couple of methods how they are made in real life. So now comes the main limitation. If these materials are available and uh, this much wastage is getting happened in the market, why people are not particularly printing these materials or having not the awareness? First one is cost. Main thing is ki cost is the main important one. If you someone say if it is not sustainable, any business model, the money has to come, money has to go. If the money has to come is less, there is not a sustainable model. Similar thing with everyone. It has to sustain your lifestyle. You need a job to sustain your lifestyle. Same thing in 3D printing also. You need, these materials are very costly. No one want to build a part using these materials. That is one main limitation why why these materials are not getting widely utilized. And another one is cost justification. So as the cost is higher, some of them, so that is the one reason. Attitudes, like people attitude also plays a big different things. People still think like the parts are not very stronger, they are not gonna sustain for long period of time. This is one other thing. And variety of materials, like we can say there are only few materials available, biocompatible materials, not many are available in the market. So that is also one major reason why people are not particularly going with these green materials. And ease of operation, some of the machines required to print these materials is not easy. They require very high costly machinery to produce. Some of them are also not having FDA approved, or COC, certification of conformity, is also not available for them. So that is one other reason people are hesitant to use these materials in the market. And the quality, like if you see layer lines on the part, if people want good looking parts, if the looks are not good, people may not buy. Like let's say if you buy AC, if it is looking ugly to the outside, if it has some layer line something, you might not want to buy that one. You will buy something which is more aesthetically pleasing. That is also one reason people are not particularly going with these materials. So in this session we covered total 4 main points. First one is what exactly are the applications, what are the applications of 3D printing, main thing. Second one is in these applications we also found out how in this application how the waste is getting generated in product development or aerospace or tooling, everywhere, or even medical. In all these areas, how this waste is getting produced, how it is hazardous to the environment, And in the third topic, we explained what are green materials, what are biocompatible materials, what are these exactly. And the fourth topic, we understand how the process, how they are made. And in the last topic, we are discussing the challenges for the 3D printing. So this is the reason and this is the importance of using the green materials, because to sustain next future. So this is all. If you have any questions, you can ask me right now. So I'm free to answer on this topic, green materials and biocompatible 3D printing, as well as applications part.
Hello. Any queries?